In this video, we're going to continue writing our list type class. So far, we've written the constructors, a default and a non-default, and we've defined our data fields for the class. Now we can write our other methods. We had 6 other methods that we had goals for creating. We can write these in any order at all. And in this video, we're going to learn how to throw exceptions in our method. So far in this class, we've used exceptions, we've caught exceptions using the try-catch block, but we haven't actually thrown exceptions in our code, so that'll be something new to look forward to as we create this next method in the list class. So the next one we're going to write is the method that retrieves a value at a specific position. So this will operate like the get method in the ArrayList class. And you probably remember that the get method in ArrayList takes an integer parameter, and that represents the array index of the value to retrieve. And then it returns the value of the object at that position within the collection. So we're going to write the same kind of method in our list class. I'm going to come over to IntelliJ. And remember, you can list these in any order you want. So I'm making a public method get. And I want it to take an integer index. And you can see I set up the return value, so it's an object. That's because the information in our array is of type object. So if we're returning one of those pieces of information, we're returning an object data type. Now let's think about what happens in the array list when you try to access an index that's out of bounds. In the get method, it throws an array index out of bounds exception. So if we want to duplicate that kind of functionality, we'll have to do the same kind of thing in our own code. So we're going to add in here the fact that this particular method has the potential to throw an index out of bounds exception. You can use autocomplete to fill it in there, or you can type the whole thing yourself. Super. Oh, and they had the array index out of bounds exception. Cool. So now we're ready to implement the body for our get method. And let's think about lists that we could have. I drew a little example. I know we haven't written the method that allows us to put information into the array yet, but just suppose that we have an array that's already been started and we stored some data in it, like maybe we have 1, 9, 8, 5, and we have a 10 item maximum size, and right now there's just those 4 data values in there. Then our data members in the class would look like this. We have the array that stores our data values, so we have 4 integers in this, and there's 4 values, so actual size is 4. And it looks like maybe we used our default constructor, so we set the max size to be 10. So the 2 possible things that can happen are the user might call our method with an index that's out of bounds. They might call it with something that doesn't exist, that's not part of our collection. So for example, if we called it with index 6, we'd think like 0, 1, 2, 3, 4, 5, 6. Well, that's a value that's way over here, and there's nothing stored there in our array. So in that case, we'd want to be able to throw an exception to say, hey, there's nothing over there. The other possibility is that the user provides an index that is in bounds, that does exist in our collection. And of course, in that case, we'd want to return the object at that index. So if they called the get method with index 3, that's 0, 1, 2, 3, we'd want to return the value 5. That's the value at that position. So we're going to have to handle both of those cases in our code. And so we're choosing between option 1 and option 2. We'll need a conditional statement in there because that's what allows us to make decisions within our code. So I'm going to set up in my object class a variable that stores the return value. So it's an object data type. And this is the value that I want to return. And we don't know what value we want to return yet. It might be something that's part of our array list or our list that we're creating in the array, or it might be that that value doesn't exist. So I'm going to initialize this variable value to be null. That just means right now the value that's in there doesn't exist. Now I need to test to figure out which of these two scenarios I'm in. So let's think about this. What allows me, based on these data fields within my collection, to know that the index 3 is good, but know that the index 6 is too big? Well, we can't compare it to maximum size because that just tells us how many total spaces are in there, but doesn't help us delimitate where the good data ends. To figure out where the last valid index is, we have to look at the actual size. The last valid index in this example was 3, which is always the actual size minus 1. So we want to test to see if the index that the user passes in as the parameter is less than actual size, then that means that the value exists. And then otherwise, if that's not true, then the index is out of bounds. So let's first think about what we want to do if the index exists. So if the index exists, we want to return the value that's at that particular index. So we want to set value equal to the array at position index. That's the space that they requested. And then at the end of our program, we want to return value. So again, we've initialized value, so it's null, means it doesn't have a existing data value yet. Then if the value exists, if it's inbounds, we set value equal to the array at position index, and we'll return that value at the end of our method. So now let's think about what should happen if the index is out of bounds. Well, in that case, we want to throw this index out of bounds exception. We just put in here, this throws array index out of bounds exception. And we have to instantiate that so that it's a new object of that data type. So this array index out of bounds exception, that's a data type. So we're calling its constructor right here to create a new exception of that particular data type. So fantastic. At this point, we've created the get method. We checked to see if the array index was too big. And if it wasn't, then we've returned the value at that index. If it was too big, then we've returned this array index out of bounds exception, which then the main program that's calling this get method has the option of either catching or allowing it to generate the exception and print the call stack trace and end the program. So the person using our class has the option of handling that exception in either way. Now, if you're thinking, hey, we should probably also check to make sure the index is not too small, that is an awesome idea. I highly recommend adding that in here. So we'd want to make sure the index, it's the smallest index we could have. If you were thinking 0, that is absolutely correct. So we want to check to make sure that the index is bigger than or equal to 0 and less than the actual size. If it is, both of those two things are true, then we're good. We have an array index inbounds. Otherwise, we want to generate this out of bounds exception. Oh, and I'm looking right here and seeing that my throws is underlined red. I have an extra S in there. You want it to just be throw new array index out of bounds exception. And at this point, I think everything's going to compile. It's compiled just to double check. We're not really at a point where our classes do a lot of stuff yet. And so we can't really write a main program and test it at this point. But just compiling it can give us some level of confidence that at least we don't have some syntax errors in here. And in fact, it does compile successfully. So that's a good sign that we're on the right track so far.